Hello, welcome to another edition of Data in the Hallway. For this episode, we're actually coming from all different parts of the world. So I'm Ray Paik, based in California. I'm home. And then I'm joined by Daniel, my co-host, based in the Netherlands. And I mean, Sunny, he's our guest today. Sunny's usually based relatively close to me in California, but you're traveling in India over the past month or so. So I guess the sun never sets in our empire, if you were to use that analogy. So it's good to see both of you. And for this episode, we wanted to talk about, I mean, this is relatively new. I mean, less than a year old when we released it with TiDB 7.1, Distributed Execution Framework. The DXF is the acronym that you can find. The easiest place to find it is on our docs pages. I'll add a link to it. But Sunny, you are very first real guest on our episode, so it's good to have you back, and thanks for joining us from India. So,
Thank you, Ray.
yeah,
I'm glad to be back, and
yeah,
it was enjoyable the first time. I'm sure it's going to be
cool.
enjoyable today too.
All right, cool. So yeah, DXF, it's mouthful, distributed execution framework. I mean, tell us like what this is, and why was this necessary? Like,
Okay, so let me
yeah.
first summarize so that we can capture the essence of what it's trying to do, right? And
Mhm.
then we can go into some more detail and discuss a little bit further. So it's
Uh,
to apportion and control resources efficiently at the cluster level to, to reduce impact on core business transactions. I mean, that's really it. And
mhm,
so now if I to go to the second part of the sentence, usually what happens is that you have, let's say, a very large DDL. Let's say you have a very large table, right? And now you want to add an index. And let's assume that table is like this, for example, like 4 terabytes, right?
mhm,
And you want to do a create index or add index on a table. This create index is going to use a huge amount of resources, compute and storage. And it's going to impact your front end load, like OLTP, OLAP, whatever it is that you're doing. So you want to figure out a way that you can spread the work across your cluster in a distributed execution framework. That's where the DXF comes from. And so once you're able to spread the load, the obvious question is, how do I control it? Does it just spread it all across the network evenly? Can I say that let's say I have some beefy storage nodes, right? And I think I can use for large tables for sorting or whatever you want to do to prepare the data for creating an index. You want to use those nodes because it's beefier, and maybe in your system you just have 3, 4 nodes that are just for this sort of work, or you've added them just to, because TiDB allows you to add and take nodes out very easily, right? And so you can say, okay, I'm going to attach some temporary storage for sorting and for temporary work that I'm going to need for adding an index. And I want to use these nodes. And you also, let's assume you think, okay, it's not that urgent to add the index. If it takes a bit longer, what is more important is it should not affect your business side of transactions. And so the distributed execution framework gives you that ability to spread it out across your cluster so that you can improve the utilization of your resources and you can control it. You can say, I can use these nodes for X part of the work and these other nodes for the Y part of the work. That's what it's really designed for. And DDL is one use case. There's like TTL, import, analyze, which you have to do anyway. And then there's backup restore. So these are the things that are currently supported because these are the things that are very urgent for us, right? These are very urgent for our users who asked for something like this. And as far as I'm aware, I don't think there's any other true distributed SQL database that has this. If there is, then somebody in the comments should tell us and enlighten us, at least for my edification, really.
yeah,
I am not aware. So
yeah,
I think
yeah.
this
I
is
mean,
a great
yeah,
innovation.
yeah. Oh, sorry. Yeah, I mean, you sort of preempted my question because the question was, is there like an equivalent feature elsewhere? But I guess the listeners can let us know, and like you said in this discussion, like in YouTube. And so, I mean, a lot of these functions, like adding index, it takes up a lot of time, but it doesn't happen, very frequently. But whenever you sort of trigger this, it could potentially impact like transaction processing or other business like critical functions that's happening, and you sort of want to make sure that the resources are well utilized so that you're really taking advantage of the distributed uh, benefits of the distributed system. Maybe I'm being too simplistic, but
No, you're
yeah,
absolutely right. Let's
yeah,
say you contrast it with something like MySQL group replication. So it'll show you the extreme end of both systems. So there is like extreme flexibility and control, and you just can't do anything in, say, in a group replication setup. So let's say you have a single writer. This is like the worst case now, right? And you want to create an index. It's a blocking operation, right? You first do everything on that single node, right? And then you externalize it and spread it across your cluster. This is like the complete opposite, not opposite, it's just a much better way of doing it, where you can break down your work and spread it and utilize your entire cluster in parallel. That is an extremely powerful thing that you can do with this technology. And I mean, data is growing, right? So we reached the limit of single node these kind of operations like 20 years ago almost, or at least 18 years ago. And in today's world, as it is, everybody's struggling with the way the data is growing. I mean, I don't, maybe it's more than exponential, whatever, factorial or whatever, right? And imagine what's going to happen 2 years down the line. If you don't have something like this, you're going to struggle. People are struggling today. I mean, 4 terabytes add index on a single table. I mean, you can make the argument that why do you need a 4 terabytes table? But we have people who probably thought the same, and it just so happened that the data grew so fast that they now have a 4 terabyte table. So what do they do? Do some retrospective sharding, resharding? No. You want a solution that solves your immediate problem, and that's what this does. So your question is spot on. I think I agree with you.
cool, cool. I mean, so I'm guessing this was developed like because of either community or user feedback. I mean, I mean, this isn't like something that was developed in vacuum, is my assumption, right?
Yeah, so
Yeah.
this actually goes with my observation about how things happen at PingCAP or around TiDB. It's very rare for people to sit back, do some navel gazing, and come up with something that they think the users may want. No, it is a very production feedback oriented way of developing. So this is a request that has come from users. And also TiDB usually people who use TiDB already have scalability problems. And scalability doesn't just mean storage of data, it is also managing that data. And as I said, managing could be like you're importing tables, you're analyzing for your optimizer, you're doing a backup restore. I mean, these are on large data sets, unless you've done it, like Daniel has done these things, right? So which is why he's not saying anything, because he understands every word, because he's felt the pain and he understands that scale changes everything. So this feature was developed from a request from our users who are running TiDB at humongous scale, and they want to simplify their work, and this is what it does. And it just, as I said at the start, it's a way that you can use your entire cluster effectively and efficiently. That's what it's for, and you want more control.
Yeah, I think the other way of doing this without this feature is sharding, and we all know how painful sharding can be. So I think this is way better.
Right. So, I mean, I assume like unless I don't think I missed it, that 4 terabyte example is probably like the one that was, is that an example from like a user or customer that we work with to develop the feature, or
No, as
no?
far as I
Oh,
know, that is our
yeah.
internal testing. Yeah, I
Oh,
use it.
okay. Wow.
Yeah, no, it's
Okay.
not. I mean, a customer may have had a 5 terabyte table. I don't know.
Okay.
But
Right.
when we tested it for performance and how
Right.
effective it was, 4
Okay.
terabyte was what we chose as a representative
Oh,
load
okay.
for. Yeah,
Right.
that's it.
Yeah. I mean, are there like a performance, like a results that you can share from that size table? Like, like things like adding index. Like, I don't know if
I've
there are any.
shared,
Yeah.
yeah, I have shared a slide earlier. I mean, we don't have a slide now, but
Yeah.
from memory, I think it was 47 minutes to add an index on a 4 terabyte table. I think it was 4
Mhm.
terabytes. Could be 10 also, but I think it was 4 terabytes.
Yeah.
Could be
Right.
10. I'll have to find this one. Maybe one
Yeah.
second. Give me a second.
Okay.
Let me just check. See, no, it's not this one. So anyway, let's say 4 terabytes. It
Yeah.
could be more. I think it was 47 minutes to add a single column index, and if you add 10
Right.
columns, it was 106 minutes.
Okay. Sort of in
Yes.
that magnitude. Yeah.
I mean, that is I mean, when I saw those numbers, I was
Right.
personally blown away. I thought, wow, man, this
Right.
is really powerful stuff.
Right. Yeah. Yeah. I mean, it shows you sort of the I mean, I think it'll give people an idea of what kind of benefits that you can get
Right.
with the feature. Yeah.
I actually asked on Twitter when I first saw those
Mhm.
numbers,
Mhm.
and I said that can anybody share numbers that they have, because I'm not aware of other people doing similar
Mhm.
testing. I have never seen anybody do this, honestly, on a single
Mhm.
table. And I remember Morgan Tucker, he's written some tool and he mentioned that his tool can do, I think it was a much smaller table, but fairly large. I can't, maybe 1
Mhm.
terabyte, I'm not. And it was like 4 times or 5 times, I can't remember, slower
Mhm.
using,
Okay.
I think,
Okay.
Spirit, I think that he had, yeah.
Right.
And that is just the cost of doing it, and then to propagate it to the nodes, I think is a separate cost in MySQL because that works on MySQL. So you're looking
Okay.
at 6 of this alter table running and then spreading
Mhm.
the log across your cluster. I think that part wasn't in this. When a table is externalized in TiDB, it is immediate. Every node sees the latest version. There
Mhm.
is no propagation over the bin log or this or that. It just
Mhm.
so
Cool.
it's an
No, I
apples
mean,
to
if you,
apples.
yeah, if you can find the tweet, I'll try to. If you can send me the link, I'll try to include it in the episode description
Oh,
too,
sure.
so people can see
Sure.
it. I think that would be cool. So, and this question's a little hard because like you said, like we're not. I mean, this is a podcast. We're not showing any slides or anything. Like architecturally, for people that are not familiar, like how is this sort of implemented in TiDB architecture? I think like what I'll do, like I said, I'll add a link in the description where they can find the architectural diagram in our documentation. But if you want to sort of verbalize some of the highlights, that would be great. So,
Sure. I mean,
yeah.
we can look at it from a very high level view and
Mhm.
then try and go down into some detail somewhere, right? So it should be fairly straightforward. I mean, it's not that difficult conceptually. So you have m number of compute nodes, you have n number of storage nodes, right? That's essentially it. And you want to use a subset of those nodes which are lightly loaded, right? To run your, in this case, let's say DDL, okay, just an easy thing to do. And let's say you want DDL to run slowly in the background. So what do you do? So the way TiDB does DDL, which is, so the execution framework is layered on top of how TiDB already does DDL, right?
Mhm.
So in the DDL system, the way the DDL is done is it writes the request to a queue. So you have a dispatcher pool, you have a scheduler pool, and you have a subtask. So I'll go to the subtask, this dispatcher pool.
Mhm.
And there are 2 kinds of DDL. So let's say create index is one of them. There's like a general one, which could be like a metadata chain, which we know, but these are the long running, right?
Mhm.
So you create a request. That request is then visible. It's like a queue that's visible to the node that owns the DDL operation. So there's this concept which I won't go to, owning it. And because it's a bit complex, when let's say the owner dies and in a type like a distributed system like TiDB, when it comes up, what happens, right? That sort of thing. And also, I think it's the distributed execution framework and not DDL. It also persists state. So if you have an extremely long running DDL, it can retrieve the state because the request is already queued. And that request is then broken down into smaller tasks, right? So now you can imagine you've taken this large task and you've broken it down into smaller tasks, right? And each of those tasks is then, think of it as interleaved execution if you're doing several things at once. So each task gets a time slice, let's say at the storage layer or at the compute layer if you're doing sorting. Right. And then each stage and state is persisted automatically in TiDB when it's working. So if a node crashes, comes up, it works. I mean, I am sort of hand waving my way through these things like crashing and coming up, but these are extremely complex things and extremely powerful things for the end user. And like in MySQL, if the node goes, everything goes and you have to start all over again. In this, if it crashes, you just start from the last point where it's, think of it as a checkpoint. So the state is the state itself of these, let's call them subtasks, right, is actually stored while it's working on this very, very large operation. So conceptually, you put it in a queue, the queue is visible to everybody. So whichever node owns whatever the DDL, it will start orchestrating the operation. Because it says, okay, the user has said, run it across the network, let's say, and there are some modes like backup, and every node does it, or some nodes do it and some nodes don't do it. So there's a lot of detail. You look at the config and you can figure out from the parameters, how many nodes you need to use, how many compute nodes you need to use, then which nodes you can attach extra storage to. So there's a lot of detail there. But the core idea is it's a queue, you pump it into a queue, and then you break it down into subtasks and you execute the subtask and the state is saved. And just like a normal DDL, when the operation completes, you put it into a completion queue, and then that is externalized and every node then sees the latest version. That's essentially it. So at the high level, it's actually quite straightforward, but the details are complex.
Right. Cool. No, I mean,
I don't claim to know that all the details either, because, to really drill down, I would have had to implement a lot of things too, but I do know it at some level.
So this is really a very interesting and complex tool, but from an end user, how difficult is it to use this? Do they have to do like a lot of configuration and monitoring of it? Or is it just like all behind the scenes?
It's all behind the scenes. You only need to worry about 4 parameters, and it's advised not to tweak them. So the thing that you would normally tweak is if you wanted to run faster. By default, the parameters are conservative to run it slowly in the background. But sometimes, you want it to run a bit faster. So then you can increase the number of rows, for example, in every small batch. I think the default is very conservative of 1,000. You can make it 10,000. I can't remember, 100,000. I can't remember. So you can increase that. You can increase the number of workers that you want working on this. So there are 4 parameters. They are, in my opinion, slightly oddly named. They don't seem to, from the name, convey what they actually do. Ideally, I think we should have had DXF in the name somewhere and more descriptive. They seem to have been inherited from some prior work, but they're just 4 parameters and they're really easy to work with, and the defaults are good enough.
One of the classical problems in computer technology, naming things.
Yes, indeed. And so, I would, if I were to make any recommendation, it would be to rename those parameters. The names don't sort of tell you exactly that, where they fit into the whole scheme of things, but it's fairly easy. The defaults are good enough.
Cool. Yeah, and then I think you mentioned like currently, I mean, this, like I said, it's relatively new. I mean, we're expecting 8.1 stable release to come out in a few months, so this is less than a year old. And you mentioned, I think we're supporting like 2 statements, add index. You mentioned the other, I think was like import into, I believe.
TTL too. TTL,
Oh,
there's
okay.
analyze, and there's backup restore.
Okay.
The current background tasks are all there. There are no foreground tasks. For example, if I want to use this to run my query in a certain way, right? Right now, you can't decide. Even if you have, let's say, 2 tie flash nodes. I think Daniel answered this question somewhere. By default, it's the optimizer that chooses what and how things need to get done. And I think, there was a user question I remember we were discussing. So that fine control you don't get at the moment, but that is one of our ambitions to leverage this framework to give users more control on how some queries are, for example, executed. I want this query to run on these nodes or go to the storage is a bit difficult because you have to go to the leader anyway, but you can at least control it from the optimizer side of things.
Cool. Yeah. I mean, thanks for elucidating us on. I only found out about this because I think we're on a trip somewhere, Sunny, you and I, and then you mentioned this to me. And I said I've never heard of it, and then finally looked it up, and yeah, I mean,
we were in LA. We were in LA.
Yeah,
and I was telling you
think,
how impressed I was with this framework. I remember I said we should talk about this. It's really good.
Yeah. Right. So yeah, I like you said, like we haven't yet. I mean, we probably should. Like, we haven't published any blog posts or anything. The only documentation you can find is actually in our docs. So yeah, I was excited about this too when I read and talked about this with you. So it's nice to have you here and to spread the word. And as Daniel's question alluded to, it's not like you don't need to do a whole lot of configuration. It's like a four parameters that you need to worry about. So hopefully people will check this out. And even the documentation page, it shouldn't take more than like 10 minutes to read through. So it's a pretty simple thing to get to speed on, I think.
Because it's such a new feature, and if I remember correctly, by default, it's not enabled. I don't think so.
Right. Yeah.
You have to enable it by default because it's a new feature.
Yeah, I don't remember the documentations because it's been a while, but I think it talks you through how you sort of turn this on or enable this.
Yes, I think it's yes.
Yeah. So.
Yeah. If I look at the documentation, it looks like we are enabling it for like 8.1 versions. So like the new version that's coming up is, then we are probably enabling it by default, but for current existing clusters, it's disabled.
Oh, okay, cool.
I remember reading somewhere that it was disabled and you have to enable it.
But yeah, I guess stay tuned for 8.1. I mean, I'm sure we'll have a presentation or webinar which we typically do with every stable releases. So, I mean, maybe, it wouldn't surprise me if that's one of the features that we highlight when we talk about 8.1. So.
Right. Cool. See, the other thing is that you could really make a webinar for each type of task that we support, because each task is executed, and at the detail level, each task is done differently. This is just like an orchestrator of how, let's say, you would do. It takes away DDL, like fast DDL, I think is what we call it, how that works, and then it orchestrates it. Then how we do import into, it orchestrates that. And the details of how import works, then we have to do that. This is how import will work. This is how TTL will work. This is how backup, recovery. So you can make a whole series of things for people who are interested. But if you want to use it, you don't have to worry about it like a VCR, then that's it. It works out of the box.
Cool.
But there are many people who like details. So
cool. Awesome. Yeah. So, I mean, stay tuned for more. And I mean, for example, when we talk about 8.1 release, we'll probably have more interesting things to talk about. So cool. I think we sort of covered everything that was sort of on our questions list for you, Sunny. As I mentioned at the beginning of this recording, I mentioned that you're currently traveling in India, and that I knew you were going to this event called GIDS in Bangalore. And then before I hit the record button, I had to ask you multiple times just to make sure I heard you right. You actually drove from Bangalore to Chennai. Like, I mean, for people that don't know, India is a huge country, and they're on like other side, pretty much on the other sides of the country. So why did you have to go to Chennai in a car? And tell us about that drive. So.
Oh, that was a fascinating day. So we have users in Chennai, TiDB users. And So, you can't disappoint them. Let's go talk to them. Let's see, find out what their problems are.
Right.
So we woke up at 2, jumped in the car at 5 a.m., drove for, I don't know, 7, 8 hours, met
Wow.
with the users, had lunch, and then we had a really nice interaction with people there, really fantastic interaction.
Right.
And initially it was very quiet, but once everybody we gave our presentation and we talked about, it was open-ended. It was really very interesting. They had some really nice ideas. And so I just honestly, I didn't feel the exhaustion from the trip, right? Anyway, so we had to come back because we had some meetings early next morning. So then we drove back and got back at 2 a.m. in the morning.
Yeah. Wow.
So,
Wow.
exciting times. But we got to eat some really nice cuisine on the way. I was very impressed with the local cuisine, like dosas and things like that. Oh man, they were fantastic.
Oh, yeah. Wow. So you spent like 15, 16 hours in the car, it sounds like.
Yeah.
Wow.
It's a miracle that we weren't we were still on talking terms, all of us who went there and came back.
Yeah. Cool. Yeah. I mean, India is one country I haven't been to, but I've always wanted to travel to. But it's a huge country. Like, I mean,
you'll love it, man.
Yeah,
You'll love it.
Yeah.
And also,
yeah.
I'm an Indian, right? I mean, I lived here for 28 years of my life. So if I
Right.
have to go to some other part of India, it's like a foreign experience, mostly like a foreign experience for me.
Yeah.
So,
right.
So I can advise you about the parts I have been to that I am very familiar with. So when I go down south, for me, there's a lot of novelty there too for me.
Yeah.
I mean, at the base level, all Indians think alike. That's not the problem. But at I would say supervision level, maybe, or even at some deeper level, I don't know. I can't read the language, for example. I can't understand how, things they say unless it's in English or Hindi, for example.
Right.
Customs are usually the same. You're respectful, you're nice, and everything. That part works everywhere in India.
Right.
So, but
Cool.
I get lost looking at the signs, and so I have to look at things. So you and I will be almost in the same boat. So
okay.
Yeah.
Cool. Yeah.
The variety and everything is great. You should go.
Yeah. Well, I mean, hopefully, fingers crossed, one of these days. But well, glad you got back to Bangalore safely. Because I mean, this is our traditional closing trivia. When Sunny was first on, he told us about his favorite bakery. I think it was in Sacramento area, and I didn't want to ask about Sacramento again, but this came very timely. And then, yeah, that's awesome. I'm glad you had a good trip and got to meet with our community members in Chennai. So cool. Well, thanks for your time. I mean, thanks for coming on. Like almost maybe not quite year to the date, but so we'll try to have you on sooner and not wait a full year. So,
Okay,
cool.
cheers, man.
All right, thanks, Daniel. Thanks, Sunny.
Thanks, Daniel. Thanks, Ray. It was a pleasure, man, as usual. Yeah.
Sure.
See you guys in California.
See you back in the office when you come back home.
Yeah, indeed.
Yeah.
Cheers, man.
All right.
See you.
Cheers.
Bye, guys. Have fun. Cheers.